How did life begin? I'm kind of fascinated with beginnings. How did life begin is a question that I think we'd all like to know. How did the universe begin? So it's right up there with a question that's tantalizing. It's a piece of knowledge that's part of the fabric of our understanding of the world. And it's something that is, I think, fascinating to people. I always, like to know how things start. There's any number of things whose beginnings, they're big things today. What did they used to be? How did it get where it got? I like building things. I like to know, well, how did things start? Well, the universe is one of those things.
I think the impact of the Simons Observatory is that it will reveal to us what really happened to the universe 13.8 billion years ago. Did it have a beginning, springing from some wild quantum turbulent state? Or what really happened is it underwent a bounce. It was originally contracting and then simply began to expand due to some phenomena that occur when it became very dense. Why is all that important? Well, because not only tells us about where the universe came from, but where it's going. It also tells us about the nature of the forces that control the universe, that control all the properties of the universe that we observe today. It makes a big difference if you have a bang or a bounce.
For the Simons Observatory, on the top of the mountain, we're going to install several telescopes of two different kinds. One is the so-called large telescope. It's got a 6-meter diameter mirror, and it's going to be about 4 stories tall. It'll have a little elevator in it. It's a pretty big object. But the really special part of the telescope is in the back. It's the camera. Can the technology match the question? I mean, that's exactly what we do in our research. We've known for a long time the signal levels that we're looking for, they're very small, order 10 nanokelvin. And so we know what kind of instrument we would have to build to be able to even approach that kind of signal size. 20 years ago, that would have been just unimaginable. But we've been working very hard to figure out how to make the detectors more and more sensitive. And these lithographic techniques where we're building now wafers like you would build a computer processor, and just like with computer processors, we're putting more and more features into these silicon wafers where we can put even some of the optical elements that was previously little lenses or macroscopic parts that you would machine. They're now all integrated on this planar silicon wafer, and that's really created an explosion in sensitivity for our field. We've gotten to the point where we can ask the question, can we see a signal from inflation in the cosmic wave background?
How does your instrument respond to a signal on the sky? Ultimately, what we have to do is say, okay, we've got this signal on the sky. It goes through the galaxy, it goes through the Earth's atmosphere, it goes through the receivers, bounces off the optics, comes into the detectors, and we get a signal, a digital signal that we record, and we then have to convert that digital signal back into a map of what's on the sky. A whole nother piece of the science we do is, first there's the hardware of building the optics, building the receiver, getting that electronic signal. And then we've got to build the software so we can use our computers to take that electronic signal, convert it back to an image of what we actually think the sky looks like. It's a challenging game because at any given moment, 99.9% of what you're picking up is not what's on the distant sky, but what's in the Earth's atmosphere. Now, the Earth's atmosphere is varying with time. So if you keep recording the signal, the effects of the Earth's atmosphere averages out, and what's left behind is the cosmological signal.
One of the challenges of our experiment is actually surprising. We're going to have 80,000 detectors out there on the mount taking data all simultaneously, and that's going to create terabytes of data that we have to move off the mountain. So what we're thinking of doing is actually taking the data and bringing an optic fiber all the way to the telescopes. And so we're going to have to dig a trench, for kilometers, and we're going to bring it over from the nearby ALMA facility, which is the big interferometer, which is about 6 kilometers away. Once the data comes, we bring it to centers within the US and other places for analysis. Then the data, though, goes to a faster system where it sits on hard disks, and there we can access it really quickly.
Most people think inflation is valid. I'm on the fence, actually. Either way, we win. Personally, I like the other theories better. It's hard for me to believe that time began. Everyone imagines that time would go on forever. But why wouldn't it have been going on forever? Why should time have started? It doesn't seem reasonable to me. It's not very aesthetic. Whereas something that oscillated between big and small and big and small and was always there was always a universe, that aesthetically is much more appealing to me. What else can I tell you?
Some people say that Galileo was not only the first astronomer to use a telescope in history, which is certainly, it seems to be the case, but that he was actually the first scientist of any kind to use the scientific method, where one has a hypothesis, perhaps tests that hypothesis, uses data, refines things about it, and throws away the parts that don't comport with the observations that he made. It tickles me that we are using basically the same kinds of technology that Galileo used 409 years ago, which is to say we're using on the Simons Observatory telescopes that are made with refracting lenses that are not unlike the lens in your eye, and that when connected to the brain of a titan like Galileo or like my colleagues that work on this project with me, that we are able to see the invisible.
Well, I'm very excited about it. We're supposed to see first light in 3 years, I think. I can't wait. I'm really excited. And I am certain that very good science is going to come out of it one way or the other. I'm not certain what's going to come out of it, but I'm sure it's going to be good science.